Yeah, hi. Once again, back on Wikipedia. Because somehow I feel safe to use Wikipedia because it's largely accepted as being in a way true. Or not. Geology of Finland. The geology of Finland is made up of a mix of geologically very young and very old materials. Common rock types are orthogneiss, granite, metavolcanics, and metasedimentary rocks. On top of these lies a widespread thin layer of unconsolidated deposits formed in a connection to the Quaternary Ice Ages. For example, eskers, till, and marine clay. The topographic relief is rather subdued because mountain massifs were worn down to a peneplain long ago. Uh, let's check out what they tell about gneiss. It's a common and widely distributed type of metamorphic rock. Gneiss is formed by high temperature and high pressure metamorphic processes acting on formations composed of igneous or sedimentary rocks. Gneiss forms a higher temperature and pressure than schist. What? Gneiss forms a higher temperature. Gneiss nearly always shows a banded texture characterized by alternate darker and lighter colored bands and without a distinctive cleavage. Gneisses are common in the ancient crust of continental shields. Some of the oldest rocks on Earth are gneisses, such as the Akasta gneiss. So, what is a metamorphic rock? They are my little adventures on Wikipedia. Metamorphic rocks arise from the transformation of existing rock to new types of rock. Let's read that again. Metamorphic rocks arise from the transformation of existing rock to new types of rock in the process called metamorphism. The original rock protolith is subjected to temperatures greater than 150 to 200 degrees Celsius, 300 to 400 Fahrenheit, and often elevated pressure of 100 megapascals, 1000 bar, or more, causing profound physical and or chemical changes. During this process, the rock remains mostly in the solid state, but gradually recrystallize to a new texture or mineral composition. The protolith may be a sedimentary, igneous, or existing metamorphic rock. The protolith may be a sedimentary, igneous, or existing metamorphic rock. Which basically means the rock's there and it just turns into something else. And one thing which is somehow important to them is temperature. So we don't have that much volcanoes here in Finland, for example, but we have so much metamorphic rocks. And let me show you something. No, actually, let's go back again. And let's check out what they have to tell about schist. Because that's something which is also quite common here. Schist is a medium-grained metamorphic rock showing pronounced schistosity. Schistosity. You look a bit schistous today. This means that the rock is composed of mineral grains easily seen with a lower hand length, orientated in such a way that the rock is easily split into thin flakes or plates. This texture reflects a high content of platy minerals such as micas, talc, chloride, graphite. These are often overlaid with more granular minerals such as feldspar or quartz. Schist. So, it's so looks a little bit like the same, like this one. But let me show you one thing. They don't talk about now, like description. Probably they talk, I just didn't read. Orthognize. Crystallized. Yeah, except for example, recrystallized. I think you really have to need electricity to get something recrystallized, induce energy into it. And it will do what it ever will do. It depends how much energy and for how long time, you know. So, we have no volcanoes in Finland, almost no geothermal activity. It's not something that it's known like in Middle Europe or where you have those hot springs everywhere. Yeah, but these people are talking that continental shields that, yeah, basically they are really old. They're really, really, really old. Yeah, no, let's don't waste further time to that. Let me show you what I wanted to show you in the first place. This one, like they told you before, that there has to be a really great temperature. And some of those rocks or metals, they don't melt under at least 1,000 degrees Celsius. There's this volcano in La Palma going off now. The lava which is pouring out there is about 1,000 degrees. And there's like stuff molten on many places on Earth, which needs much more heat than comes out of a volcano. And that's a lightning bolt, and I somehow noticed that there is no quartz in those rocks. So I just thought it could it be that somehow quartz was working as gas shield when it happened. And there's many boulders around in Finland everywhere to find, and if this kind of event happens, there's like it splatters stuff away. Doesn't matter if it's the size of a house or a car. It just will fly through the air somewhere. Because I will make once a video about the boulders which are here. If it was really a glacier which carried those here, you would expect that they would be round, you know. I have seen those, like from a real glacier. They're like round because they got like, mixed up with the other rocks and they get round. They are not sharp edged anymore. But many, many of those rocks what you find here, just in the middle of somewhere, they really don't belong there. They are not round at all. And that's an actual Google Earth picture. Here we have the same what we saw before. This one, that's the same side, different perspective. A little bit more far away. And this is the example from cloud to ground discharge, which would indicate that there would come some really big energy input from outside, from space. The sun, haha, for example. And if we go a little bit more far away, it can also be that it happened through ground to ground discharge. And for example, I don't know if it's possible to zoom in here. No, you don't see. I just thought that somewhere here is the Eye of Africa, which could be basically this thing. Yeah, that's how you induce energy and heat and all this stuff into rock, which already has been there before, and it gets transformed. And these things happens over and over again because we have the sun cycle, 400 years. Well, let's start with the small one: 11, 400, 6,000, 12,000 year cycle of the sun. We have an ongoing pole shift. Our magnetosphere is weakening. At the moment, there is some geomagnetic activity. We have a volcano going off here. Here are volcanoes. Somewhere here is Italy. It's a straight line. And now also some thunderstorms going the same way. Did the telluric currents of Earth shifted? Did the crust of Earth shifted? Are those magnet maps that we use, or I was watching at, are they still accurate? Like we have seen, there's the crust shifting on Mars. The magnetic imprint isn't at the same spot anymore as the mountains and the valleys are. This is what the crust shift means, because most of the planet's surface got forged or formed electrically, so it will leave some fingerprint and a magnetic fingerprint into the ground. So if the crust shifts on some places, the imprint will stay at the same place, but the landscape moves on. So if you would have this kind of mountain range which would have been positively charged, and now the crust is shifting, the positively charged region is probably at another place than the mountains. So the weather, the actual weather, would react to that, and the ways it will react, it will always react correctly. There are no coincidences. It's just really complex, the whole system. That's why it's a little bit hard to cope with it. But there are basically no mysteries. There's just a lack of data and lack of time to figure it all out. Yeah, but so much from this time. I forgot what I was about to talk in the first place. Thanks. Bye.